All right, everyone. Welcome to our Tech Talk. I hope everyone's doing well. Today we have Will Petillo here with us, and they're going to talk about fast and scalable programming in Unity. So thank you for being here and take it away.
Hi there, everyone. I'm Will Petillo. Thank you for joining. I'm getting a little sense here from a few of the responses that there's actually a fairly high level of background in software development, but very mixed in terms of Unity development specific. So just in case anyone doesn't know, Unity is a game engine main competitor to Unreal, and it's a little bit more of a uh, kind of you design it yourself. Well, guessing some of you know that already. Anyway, so I'm going to share my screen and just go with the full screen here. Okay, and trying to maximize it. Guess it might not do that on Zoom. Okay, there it is. All right. I'll start with my background is I've been programming for about 7 years and working as a professional freelancer for about half of that. So freelancing for me is I find people who have some game that they've always wanted to build and they don't have the skills to actually make it. And so then they hire out some of the programming, and which is where I would help them with. Worked on a number of different projects. The largest one was Rogue Invader, which is available on the Steam and Epic Game Store. Uh, and a bunch of other smaller projects besides that. One common theme I've noticed in a bunch of them is in almost every case, there were some prior developers who they had to fire because the progress had slowed down to a stop. And client doesn't necessarily know this, but like usually the reason for that is an accumulation of technical debt, where basically because of decisions that are made throughout the process, the developers have to spend more and more of their time working around their own code rather than adding new features. And every time you add something, something breaks, fix that, something else breaks, fix that, something else breaks, and fix that, and the whole thing falls apart. Eventually, the client gets frustrated, and you often have to start over at that point, which is not good. So having like code quality is, can be pedantic when you're dealing with a game jam or whether you're just learning. But when you're trying to work at scale or it's for a client, it's really non-negotiable. A little more about myself is I have my own game studios and Marmot Digital, where I'm working on a couple of projects, including bullet hell called Oscillarium and a little puzzle type game called Checkers Survivors. And you can find free demos of each of these on my itch page, Will9371. I also have a number of public repositories, including a code library of a bunch of scripts that I like, general purpose utility scripts I take with me from project to project. It's also available for free on Playcraft. Most of the examples that I show will be from that library. So if you if any of them look useful and you want to use them, that's where you can find it. I have a couple of different YouTube channels. For game dev related stuff, I have Zen Marmot Digital, including a number of lectures I've given at a local meetup at Unity PDX. And then I also have a channel that's just under my name, and that's for more AI related kinds of things. I think that's good for that. So the overview of this talk is my goal is to break the commonly perceived trade-off between quick and dirty versus proper development. That's, say, looking for win-wins between those two. And I'll start with some core concepts about what good programming is, then go into the Unity event-driven method that illustrates some of the core ideas, and then find the limitations of that, and then move on to another approach that's more just based on composition with plain C#. So some of the core ideas here is that there's a lot of debates online about like whether a technique like a singleton, for example, is good or bad. Really, all of that can be easily misguided. The important thing to know is that code is writing and writing is communication. So every choice that you make should mean something and be justifiable, not just because it works. It should be a reflection of what you're trying to say. And Next is that if you want to manage your complexity so it doesn't get out of hand, then the complexity needs to be measurable so that you know whether a choice makes more or less of it. And I want to push back against the idea that complexity is this subjective thing where you can just look at it and kind of have a feeling for how complex it is. Really, there's three types that matter. One is cognitive load. That is how much stuff I need to hold in mind in order to understand the bit that I'm looking at. And this is really bad. This is what you want to minimize as much as possible. Second is sophistication, which is how much stuff I need to know in order to understand what I'm looking at. So like an if-else statement is very low sophistication. A ternary operator, it's like an if-else, but with a question mark and a colon. That's a little bit more sophisticated. A ternary, a lambda expression would be more sophisticated. Doesn't matter if you know what that is or not. And that is like, it's okay, use it when you need it. Don't use more than you need. And then lastly is subtlety, which is the amount of reasoning that goes into making decisions. And that's something that you can like lean into as hard as you can. Ideally, gaining more experience is the process of gaining more subtlety. Next core idea, for those of you who've been programming for a while, this will be familiar, but I'll have a novel take on it, is called the single responsibility principle. And this is the idea that every class, function, etc., should be responsible for a single thing. Now, what is a single thing is kind of a fuzzy idea. So Robert C. Martin in Clean Code defined this as a single reason to change. But both of these definitions, I feel, don't really work because it's very easy to come up with examples that fit the definition, but miss the spirit. So as a kind of comical example, imagine a class called Game Manager. What is its single responsibility? Well, it manages the state of the game. What is its single reason to change? The game specification changes. And the issue here is that if you take it abstract enough, you can include anything. So this leads to the definition that I like using, which is a single concept operating at a single level of abstraction. So if I take that game manager counterexample and imagine like we're looking inside of it, what you might see in there is that it controls a flow of states that the game can be in, such as your playing state, your options menu, the start state, and so on. And then also defines what's happening in each of those larger states. And that's where the problem is. If you were to delegate what happens in each of those states to helper classes, for example, then it would be good because then Game Manager would just be managing these flow of these larger states, and what happens in them is outside of it. Next core idea is dry, or don't repeat yourself. This is the idea that non-trivial code blocks should be reused rather than copy-pasted. In fact, if you're just learning programming, you would actually probably be well served by deactivating the Control-C, Control-V commands from your keyboard entirely. Now, the practical rationale for dry is that there's just less code because you're not repeating it. And more importantly, that there's fewer things that you have to remember to update if something changes. So if you have the same code block in a bunch of places, you realize there's a bug, you fix it. Now you have to remember all the other places where you need to fix it as well. And that's a very error prone. However, there's a deeper rationale, in my opinion, to dry, which is that if the same code is needed in multiple places, that's not a coincidence. It points to some concept that deserves to have a name. And so if you have this block of code that's used in multiple places, if you make that into a function, then you give a name to that function and you describe what that concept is. And an effect of that is you've now separated the abstractions. Rather than a function having a bunch of parts and there's a block that's like, a lower level of detail inside of it, you separate those out. Now your function is working on one level of abstraction again. And that allows you to follow that definition of single responsibility that I gave earlier. So these ideas should help each other out. Okay, now moving from the kind of general theoretical stuff to things that are a little bit more practical and specific to Unity. I'm going to talk a bit about Unity events. And these, I think, is a very underutilized feature in the game engine. Well, actually, people use it all the time. They just don't know about it. So if you've worked with Unity pretty much at all, and you've used the user interface system that's built into it, then you've probably worked with buttons. It's something you set a button, you click on it, it does stuff. And one thing you might notice in the built-in button component is that it has this thing down here for on click, where you can just add things that happen when the player clicks a button. And this can then call public methods in any number of other things. So you would drag an object from the hierarchy, put it in here, then you'd select a component, and then within the component, you would select a public method, and then you might optionally be able to send some data towards it. I'm noticing there is a raised hand.
Sherry, if you have a question, go ahead and ask your question. I'm not
Oh,
sure if that's a mistake or not.
there is a statement, we can only see the dry slide. That is good to know. Is it changing now?
Yes.
Okay, I'll assume that is good. Yeah, feel free to just toss that in the chat if you see something else like that. Let's see. Oh, good. You can see the next slide now. Yes. So this on click, this is the thing that I'm pointing to. So you would drag an object from the hierarchy in Unity here. Then you would select one of the components on that object. Then within that, you would select a public method, optionally send some data. So this is a built-in component in Unity. Now, the thing is, what's not as well known is that you can actually, under the hood, this is using a Unity event, and you can make those yourself. So as a very simple example of this, that's actually useful, there's a script that's in my libraries called validate event, where it has a Boolean trigger. It's just this box that creates this box over here, and a Unity event response, which creates one of these little list dropdown things. And effectively what this does is the core of this is there's this method here called onValidate. This is something that's built into Unity that whenever something in the editor changes, this gets called. So for example, if the user clicks this on trigger button, what will happen is the checkbox will immediately disappear, or the check will immediately disappear. And this response, all the methods called in here, will then get called. So in this case, it's being used to call print to console.print and just printing hello world to the console. But I could use this for any number of other things. So this is actually a really useful component for testing. So let's say I have a game with a spawner in it, and I want to be able to spawn enemies, to just test things out whenever I feel like it from the editor. But I don't want to write special test logic because, to make it run in ways that I don't actually want it to run when I'm playing the game. I could just have a public spawn enemy method, in some script, set up a validate event, connect it to that, and then click this whenever I want to add an enemy into the game, or any number of other things. Another example that I wrote this one years ago, and I've never really needed to change it because it's quite useful, is keyboard input, where I can specify any number of bindings in the editor, set which keys I want, whether it's going to be continuous, press up, press down, and then what happens in response. In this case, I seem to be using it for a physics-based movement system. But I could also use it for a combat system, an inventory, hotkeys for debugging, like little cheat codes, whatever. Another example is respond to custom tag. Let's check the chat here. Here or this. Okay, noting that there is a little bit of lag. Got it. I'll describe what I'm pointing to instead of just relying on the cursor. So this next one is respond to custom tag. So Unity objects have these tags on them, and it's in the upper right, top part of the inspector. And these can be helpful for identifying things, but it can be kind of limited For one thing, it's based on strings, so you have to type them exactly. But another is that an object can only have one tag. And so that can be a little bit limiting at times. So I've created this component called custom tags, where you can create, and it's in the bottom right of the slide here, where I can create an array of things to look for. And so right now I'm using these things called scriptable objects. What scriptable objects are is a whole talk in itself. For now, you can just know that they're data containers that you can create as little asset files in a project. The type of data container I'm using here are just empty. There's no data, there's no methods in it. They're just asset files. And so this one, it has the player on it. And then there's this other component called respond to custom tag, which is on the left side, where whenever this object touches something, and I can specify what kind of touch it is in these little drop downs on the touch filter, then I check whether the thing that's just been touched has one of the tags in this valid tags section. And then if so, something happens. In this case, it's checks for when the thing it contacts is the player, and if it is, it looks like a kind of a scene change happens right here. But if I wanted to require multiple tags or like one of several things, I could do that. So you can imagine a lot of uses for this respond to custom tag, like the player walks into a region that causes some enemies to spawn, or you step on a pressure plate, it causes a door to open, any number of things that involve collisions. So the benefits of Unity events, I'm on the next slide now. The core idea is that you can call public methods in other components without knowing what type of class they're in. So typically, when you're like just writing code, you would need to get a reference to the other component, and then use like a dot notation to call things from it. Which one is the scriptable tag? I don't feel like I quite understand that assumption, but just the core ideas of this slide here is that there are scriptable objects that are these like asset files that I've like used to fill in. It's got this little blue icon to the left of it. And so those would exist just in the project. And then the custom tags is the thing that like labels the something like as a player or as an enemy or so on. And then over here in respond to custom tag mono, this specifies what it's looking for. They're the things that are in these fields, like element 0 on. So respond to custom tags, trigger binding, tag filter, valid tags, element 0. Yeah, if you get okay, that's unfortunate there's a lag. I wonder if there's going to be a little less lag if I don't have it maximized. Because normally Zoom is like a quarter of a second lag or something, but not like that long. In any case, though, the slides will be available later. And as long as you kind of get the over idea of the core idea I want to present here is that you have these context independent components. Oh, okay. Is that you have these context independent components that you could use in a lot of different places. And that's the real idea I want to get at. So with the respond to custom tag, it's like you have this general purpose collision detection system that doesn't care about how it's used. In keyboard input, it's a way of just getting keyboard input so that it doesn't have to be in the code directly. So the core idea is also that you can call public methods without knowing what type of class they're in. So yeah, typically in code, you would have to like get the type either through a get component or through a public reference or something. And then you'd use like a dot notation to call things in another script. And that assumes that you know what type it is. So if it's going to vary, so like if I were to use keyboard input just in code, I don't know what type it is in advance. And And so if that changes, then I have to use something tricky like inheritance or interfaces or some way of being able to make the type a variable. And that can get kind of complicated. But with Unity events, you don't have to worry about any of that. Also, when you're connecting instances to each other, then let's see. Yeah, then you just don't have to create dependencies in your code. So when a particular script is relying on the thing that's interacting with having a special type, well, if that type changes, now it's broken. With Unity events, you're not really worrying about that. And then also that being context independent means you can bring it across projects and it's likely to be useful again and again and again. Another general advantage is that because it's exposed in the editor, then designers are able to control the functionality. Uh, and this is really useful, especially as a freelancer, because typically the game designer is deciding how to lay out levels, where to place things, and like what happens. And then as a programmer, I'm just building systems, like general purpose building blocks that the designer can put together however they like. So if they want to make little changes, rather than having to poke me and get me, distract me from whatever I'm working on and make that little change, they can just make the change themselves by rearranging these component building blocks. So what happens then if you take this idea to its extreme and try to make everything as building blocks that are general purpose? And this leads to what I call Unity event-driven programming, where every script, follows the same process, where you take some set of inputs, and these can be in the form of engine called methods like start and update, or they can be public methods that are called by other scripts that you've written. Then there's some kind of process where stuff happens, and or maybe you're changing state. And then at the end, you send output through Unity events of some kind. And let's see. Here is an example of something following this process. And this is a face target. So if we look at the inputs here, there's update, so void update, about 2/3 of the way down. And so this is going to be called by the Unity engine every frame. So that's one form of input. Another form of input is near the top. There's a public void set target, public void clear target. This is a way that other scripts can set and clear the target. Then in terms of what happens as the process, if there's no target, it does nothing. And if there is, it decides whether it's going to turn based on a minimum and maximum angle. Details of the script aren't super important, just to get like what is being scoped here. And then if it is turning, then we calculate which way to turn and then send the result out somewhere else. The key idea that I want to convey here is that this script doesn't need to care about the target selection system. That could be done by a player clicking things. It could be done by an AI using some kind of its own sort of vision. It could be, anything really. And also the way this calculation is used, this doesn't have to care about that either. It could be something that's like a direct rotating a transform directly. It could be applying torque so that it has more of an acceleration that is more realistic. Or it could be just be creating like a visual signal to the player. So the purpose of the kind of context where you would use something like face target would be like a turret, for example. It's mounted on a thing and it's detected the player and it wants to like turn and face towards them. That would be one usage. Okay. So one caution I want to make with Unity events, so these are just some like nuisance level things, is that there are some limitations that they're not fully built out by Unity. So one of them is dynamic arguments. You'll notice in this face target example, at the very end, I call onTurn.invoke and send axis. Axis is a vector3, and it's a variable. It could be up, it could be down. I could put whatever vector3 data in here. And And the type of onTurn is vector3 event. Vector3 event is not built into Unity. This is a custom type. And the reason I'm able to use that is because I have some boilerplate code somewhere else in my project, just line 6 on this slide, where it says serializable public class vector3 event inherits from Unity event of type vector3. And just by having that line, now I'm able to send vector3s using this keyword. All these other lines are just various other types that I've thought of that I might want to send at some point. So a vector2, a Boolean, an integer, a string, game object, color, list of arrays, or list of transforms, and so on. And you can send anything this way. You can send multiple arguments, you can send lists, you can send arrays. So it's just a little bit of extra boilerplate every time there's a new type you want to send. Another limitation that's a bit more annoying is for certain types of static variables. So if I go back to my hello world example, in this print to console, I'm sending a string. So this is a static argument I'm sending. I type it in the inspector, and every time this Unity event occurs, it's sending hello world, not something else. And that works great for strings, but if I wanted to send a static vector3, for example, that wouldn't work. It just wouldn't be able to enter that stuff in. Same for enums and a lot of other types. So one way you can work around that is, well, one of the types you can send is a scriptable object. And a scriptable object can contain whatever data you like. So if you wanted to send a vector3, you could create a scriptable object that has a vector3 inside of it, and then the receiver would take that scriptable object and pull the vector3 from it. Bit of a nuisance, it's a couple extra steps, but it allows you to overcome that limitation, and it works for anything. Okay, and then this whole script here with all these types, this is just something I copy with me from project to project, so I don't have to keep typing this stuff. Okay, so that's Unity events in a nutshell. The next question is, when should you use them? And there's two core questions that I think about here. First one is, does the direction of causality match the direction of dependency? And these are jargon terms I made up, so I'll define them. A direction of causality is when A happens, then B happens. So for example, I pick up a coin and I get points. I add to my score. And so you could imagine that this is being built by having a coin pickup system and a score system. In that case, coin pickup is A, score is B. So you pick up the coin, causes the score to go up. Direction of dependency is a little bit more philosophical, and it kind of looks to, does A by its nature depend on B, or does it make more sense to have B depend on A? So does picking up coins require the existence of score, or does score require the existence of coins that can be picked up? The second question is the connection between concepts or instances? That is, are the scripts like intrinsically related based on the nature of what they are? For example, a realistic movement system could be said to rely on physics. If you don't have reference to physics, it just doesn't make any sense. On the other hand, or are they brought together just by circumstances of level design, for example? So a good example of this would be stepping on a switch to open a door. It doesn't make sense to say that switches depend on doors, because a switch could turn on a light, it could trigger an enemy spawner, it could do all sorts of things. And then likewise, it doesn't make sense for a door to depend on switches, because it could be opened by pushing it, it could be opened by putting a key in a lock, it could be opened by a pressure plate, or by some event. Neither one really depends on the other. It's just that this switch opens that door. It's instance to instance. So you put these together, and I have a little graph. So if it's A to B reference, the first one causes the second thing, then this would be a place to use a direct reference, your standard dot notation, when you normally have scripts communicate with each other. If it's A to B, instance to instance, that would be a good place for Unity events. If it's B to A, that is, so for example, the score relies on the coins, then you could use a C# event. So saying exactly what these are is a little bit out of scope, but if you're looking at someone else's code and you see like the action keyword, and then you're like plus equaling methods together, very likely you're dealing with C# events. And then lastly, if it's B to A and instance to instance, there is this talk on Unite Austin 2017 called Game Architecture with Scriptable Objects. I have a link to this here. I'll try to make sure it goes out to be in the description. And he goes over a bunch of ways to use scriptable objects in Unity, and in particular goes over this kind of tricky way of having components calling each other through the editor. I'm not going to go into detail as to exactly what that is, but if you watch that, this is the context. It goes into this quadrant. So from that description, actually, I'm going to pause for a second and give people to write in the chat or say aloud if you feel like it. Just think about that example that I gave of coin and score. Which quadrant do you think that should be in? Is it A to B or B to A? Is it concept or instance? So I'll just give a moment, people to just throw out what they think. Seeing a direct message from Sherry suggesting that it's in the concept quadrant. Would it be A to B or B to A? Anyone else, feel free to chime in too. I'm fine with using voice. Okay, well, I think I'll pause it there. You can think about that some more. Ultimately, it's going to depend on the project. Okay, so we got one answer is direct reference, so A to B and conceptual. So this would be saying that the pickup system relies on the existence of score. And so in code, I would just say when I pick something up, I tell the score to increment. And that could be true. Yeah, that's a totally valid answer. Ultimately, it's going to depend on the game. One thing that could potentially throw that off, depending on the game design, is if, say, when enemies walk around and they touch coins, and do those get picked up? And if yes, well, then it wouldn't really make sense for the score to go up. But maybe that doesn't happen. Maybe they just walk through coins and it only counts if the player touches them, in which case it'd be okay. So yeah, ultimately it all depends. But I think having it a Unity event driven is a kind of a safe approach because it's not relying on any assumptions. But I think there's a very good case to be made for direct references. I think also C# events could be very valid because the scoring system, because if you think of coins as being like a part of the world that go into your inventory, and scores this kind of arbitrary thing that's like meta part of the world, and so that it's just listening to various things. You could make an argument for that one as well. Okay, so now I'll go into some deeper problems with Unity events, which lead to a different thing. So I use this Unity event-driven approach for building almost all of Rogue Invader. So it can scale, but there are definitely approaches. There are occasions where it was more trouble than it was worth. In particular, when following it too strictly requires just tons and tons of components. So for example, like I have two components that like work well independently, but then I have to have like a 1 or 2 line thing that like converts between them, like switching a Boolean to a string or whatever. And then, that's just unnecessary work that would have just been like 1 line in code, and now I have to make another component for it. Or also, if you have a really complex system with like that has a lot of different parts to it, and now you're putting in all of these connections, it can be harder to understand, like looking at all those through the hierarchy than it would be if they were just written in code. So that leads to the next technique, which is composition with plain C#. So actually, rather than talk about this, I'll just go straight to an example. This is that face target from before. Let's see. Oh, would the least scalable option be scriptable objects? I don't know if it'd be more or less scalable. It's a question of how natural it is, and whether like it just gets confusing to read. So a scriptable object based approach, um, you would like have the connections like on each coin, like going to the score. Um, yeah, I mean it could, again, it's all dependent on the game, really. So that one I deliberately chose that as a somewhat ambiguous example. Um, so next is this face target. This is a rewrite of that Unity event driven one that I showed before. It does the same thing, and that's important because something I want to emphasize is that whole way of separating concerns out and having a very limited scope to your scripts that has a very clear set of inputs, a clear set of outputs. It's very clear what it does. And if you want something that does something different, you just write a new thing and swap it out. That's good. We want to keep that. We just don't want to have everything just be these tiny components connected to everything. So some things you'll notice that are different here is instead of inheriting from mono behavior, this colon mono behavior that was on the other one, it's just a regular public class, serializable, so that these features will show up in the inspector. And it does the same thing as before, but instead of invoking a Unity event at the end, it returns a vector3. Also, this update is going to be called from a different script rather than being called from the engine. And the value of writing it this way is now you could have another one of these. So in a Unity event-driven way, you would have one script for target selection, and then that would send data to face target, and then face target would send data to movement. You'd have like 3 components connected to each other in the editor. In this way, you would have one script that handles target selection facing, like, that has a reference to face target, to target selection, and to rotation, and it just connects them together in code. Because honestly, you don't really need to give this level of control to the designer. And so you could just have like a turret script that delegates everything, all of its features out, and this would be one thing that's being delegated. Now, if you wanted to preserve face target just as a standalone component that could be, that's not like tied to anything else, then you could do that by having, I use the convention putting mono as a suffix. And this just delegates all of the actual work to face target, but then just handles the input of getting the update from the engine, public void for setting and clearing target, and then sending out the Unity event. Question: what does a turret script mean? So that would mean like if I built a prefab, so like an object that I can put in the game that's a turret, and I would just create a script of mono behavior type, call it turret, attach it to that. That's basically it. And the thing is, a naive way of going about it would be to put all of that functionality in one script, and then it would get kind of long and be doing a bunch of different things. And some of that features would be stuff that I would need in other scripts, like a regular enemy or maybe a player or something, and then I would be copying it around. So like that's not very good. And then the Unity event-driven way is, well, I wouldn't have a turret at all. I just have all the little parts to it and communicate them together. But then, that could get lots of components. So instead, I'm kind of combining the best of both worlds, and I have a turret script, but it delegates all the work out to other things. I'm going to skip over this example for the interest of time. This is a system for Arc Teleport in virtual reality. I have it up on my Playcraft GitHub repository. But basically, this is just a bunch of components all strung together, relying on each other. And in a composition version, then you have things like You have the parabolic arc calculates an angle and it gets some points, and then you send the points to find hits and path, to find obstructions. I could go into this a bunch. As for where the GitHub repo is, I'll be sending a link after the talk, so it'll be available in the recording description. But basically, it's my GitHub username is will9371, and the specific repository is called Playcraft. But I'll put that up at the end. Okay, so a couple of limitations I'll caution about this composition-based approach is coroutines are something that are occasionally useful if you want something to happen over time. And coroutines are a part of mono behavior. And that's like, and so yeah, if you're not inheriting from mono behavior, you can't use coroutines. A way you can get around that, so let's say in face target, I wanted to use a coroutine, so it's like something that's happening over time. I could have a variable of type mono behavior, and then whatever is creating face target, so whether it's at this face target mono, would then send itself to fill in that mono behavior field, and then face target could say mono.start coroutine. If you're not familiar with coroutines, then you can ignore that. Just know that there's a workaround if you run into that problem. And this other one, I'll not bother with that. So in conclusion, use single responsibility and dry to guide what things you make as abstractions and what to delegate. And then Unity event-driven code is a really great way to practice designing your scripts with a very clear scope and also build up a personal library as you go, so that rather than code getting more and more complicated and more to keep track of, you're just building these isolated things that don't care about anything else, and so you don't have to worry about them. And then with each thing you create, that's more resources you can leverage so that your development gets faster rather than slower over time. Now that runs into problems when you have too many components. And so once you get to that point, you can switch to the helper class, plain C# version. And because they handle the same kind of scope, the transition between them is fairly seamless. So you can switch whenever you feel ready for it. You'll still occasionally need the more complicated computer science techniques like, inheritance and interfaces and strategy pattern and all that stuff, but not nearly as often. And because you don't need those as often anymore, you don't need to plan quite as much as to which one to use, because you can just code with confidence that, as long as you stay disciplined and you manage your scope of each class, then you're not going to paint yourself into a corner. And that is all. Thank you for watching. I'm going to end with being open to questions. Also, look up some of the references that I mentioned and throw them into the chat.
All right, that was great. Thank you so much for that awesome presentation. Let's see if there are some questions in the chat. So as you guys might know, there's a few different people you can send it to. So, Will, if any questions come through you, I might not be able to see it, uh, but let us know.
Okay, yeah, I'll make sure to read aloud any questions before I say them.
And we'll just share his GitHub in there so you guys can check it out.
And then also have my itch page, which has a probability calculator tool, a narrative game, and then a couple of other game demos. And then I actually also list Rogue Invader on Steam.
Also, I'm going to reshare your presentation in case people join in later aren't able to see it.
Sure.
That also should be in the chat.
Also, so this is the Rogue Invader, kind of this side-scrolling pixel art shooter game. Okay, I think I'll stop share.
All right, any questions? I'll give you guys a few more minutes. I do have a question. It's more related to, as you know, some of the students just actually finish their boot camp.
Mhm.
And you've been working in the industry for a while, and I'm wondering if you have any tips for people who are entering the industry. Um, and also, once they do, I know everyone's position is different, but also what does your day-to-day job look like?
Okay. Yeah, I'll start with the day-to-day job. The thing that's really nice about freelancing is I can set my own hours pretty much as long as the client agrees to them. And that's something I could just kind of set up on a one-on-one. Typically, I work with just individuals who are usually fairly chill. Um, so that's pretty good as long as I get things done at a reasonable rate that I can set when that is. They'll start by sending me a specification. I'll pick some part of it that I think makes sense to work on, get some more details about it. Typically, we'll have a Trello page, break it up into tasks, and then I just start going through those, finishing them, uploading them through some kind of version control system, and then the client can say whether they approve of them or not while I work on the next thing. In terms of breaking into it, it's can be a little overwhelming at first because it's like hard to know where to start. Uh, most of the jobs that I found have been through just kind of paying attention to looking for work forums on things like the Portland Indie Game Squad. They have a channel for looking for work and just other job listings available. One tip that I would give for that is don't worry if a job listing doesn't look professional. If it's like someone just says like I'm looking for someone to help me with this thing and like and then they link to a design document that doesn't really make any sense. Um that's like writing job listings is a skill. And just like you wouldn't want someone to not hire you because you didn't happen to know some specific algorithm to write on a whiteboard, it's not really fair to push away a client just because they don't know how to ask for help in that way. Um, Now, that said, it is important to protect yourself, but the way you do that is one, by having a good contract, and second, by talking to them and kind of getting a feel for who they are, and then having a contract to enforce that. Uh, and for so like a lot of the jobs that I've applied have been because like it wasn't a very good listing and no one else bothered with it. And then also, once you get your first job, then you can start relying on references to get subsequent jobs, and it gets a lot easier after your first one. And let's see how ask that related question to charge by the project or by the hour. By the hour, definitely. Don't even consider other options. The reason for that is if it's very tempting. I started out with going actually I go into this in a lot more detail on my YouTube channel where I have a whole talk on getting a job. But core idea of this is if you charge by like a milestone, that's very tempting because that's what the client ultimately cares about and you want to reduce their risk. But the thing is, what you'll run into is you take a task, you think you have a good understanding of what it is, you come up with a good estimate, and because you've learned how to estimate, it's a good estimate, and you've given yourself some buffer. But then you get to the end, and the client says, "Oh, there's a bunch of other things that I had in mind as part of this task." And now you have a conflict of interest. You want to interpret the task in the way that involves the less work, and the client wants to interpret the task in the way that gets them the most. And now you've set up antagonism between yourself and the client with every single thing that you work on. And that's going to deteriorate your relationship over time. Now, unless the client can perfectly specify everything so that you're on exactly the same page from the beginning, and that's true of like larger corporate clients, but for the kind of people that I work with, they can't specify anything. And like I write the specification based on talking to them. And unless I'm willing to spend like 100 hours in meetings before starting work, then it's just not feasible to get a realistic description. So when I charge by the hour, if I take the complex interpretation, great, I get paid more. The simple interpretation, great, I work less. Like I don't have to care. The client gets to make the choice based off of trade-offs, and that's how it should be. Uh, let's see. Um,
Seems like you've come across a few situations.
Yeah, so the way I would describe, like, in terms of protecting yourself, there's kind of like a pyramid where um there are some clients who are awesome and golden and amazing to work with. And then there's a very, very small minority who are trying to rip you off. Like those are rare. But the really good ones are also kind of rare. Most clients want to be good. They want to be good partners and everything else and pay you fairly, but they don't really understand what they're doing. They don't get the business. They don't get what you're working on. They don't know how to communicate correctly. So like they're acting in good faith, but just don't really know, and they want to protect themselves. Um, and so like basically, yeah, you need to make sure that their failures of skill don't hurt you. Um, and yeah, contract is part of that, but then other part of it is setting things up so you don't have adverse incentives. Let's see, a question from Ben here. I would love to hear about how you created your own studio and managed the business side of that. Yeah, there is. So really, the answer in my case was having a financial runway, and outside support as well. The creating a business like through an LLC, it's like a $50 form that takes like not very long to set up. The main thing is if you want to work with other people, like hire out artists or musicians, for example, you need to have a contract. Talk to a lawyer. It's not something you can just use a template that you find online because there's a lot of um, lawyers have templates, so it's not that expensive. It's like a couple $100s to get a good lawyer approved contract. Um, but like there's certain questions that they have to ask that you might not think to ask that need to be in there. And then besides that, just kind of tracking. I guess another important thing on the business side of it is scoping your games so that you're not working on the same project for years on end. And so make sure that you can build something that you can test whether audiences are interested in it after a few months of development. And then you know whether to continue on that idea or not. Um, let's see. How long does writing a specification take? Um, and it's all about the level of detail. So I'd say that's a pretty involved process. That's not easy. I think the biggest challenge that clients have in writing specifications, or the most annoying one anyway, is that what's the best kind of specification is like a set of drawings of what should happen, of what the user is going to see under various states and like what happens between them. And what they'll often try to do is like try to write pseudocode for you, but they don't know how to code, and so it doesn't make any sense. And start like describing like how things should work, but that's your job. Um, and uh, but yeah, I think basically a really full specification, is you should be able to read it and imagine playing the game just off of reading that, and for that imagination to be accurate. And it also takes a lot of back and forth. Even someone who's really good at writing something, there's going to be things that you can ask about, like, hey, what if this happens that they need to answer. So it's an ongoing thing. Let's see, what is the tech stack? Unity game engine. That's pretty much gives me everything. I use Writer as a code editor because it just has some features of being able to say, like, if I click on a variable, I can say all the places that it's been referenced, which is handy for debugging. If you're starting out, Visual Studio Code is free and works pretty well and doesn't take forever to open. And then assets from the asset store can be good. I'd say if you're freelancing, pay for those yourself because it's very not uncommon for a client to argue for an hour at $40 an hour as to whether to buy a $15 asset. So like just buy them. Like don't charge for the nickel and diming. You get your money from your hourly rate. Uh, and also in terms of setting an hourly rate, uh, roughly double what you would expect to make in just a like clock in, clock out sort of job, because they're paying extra for that kind of flexibility and you managing your own taxes and so on. Rider, so RIDER. And it's made by JetBrains is the company. So that's not free. It's a pay by the year. It's not cheap either. If coding is your job, it's worth paying a little bit for it, and it's probably the best. I use a Windows computer, but some of the clients use Mac. And actually, for game development, having access to both Windows and Mac is really nice because there are some errors that only show up on different types of builds. So being able to test across all of them is very nice. Let's see. There's a lot of stuff in the chat, and a lot of it's just is comments. Okay. There's a question here. How valuable are attending game jams and networking for job searching? I think game jams are really good for finding collaborators and like other peers that like you like to work with. So sometimes when I'm working with a client and there's like something that they want that's outside of my ability, like they want a 3D modeler, for example, uh, then I'll recommend people based on people I've liked working with at game jams. So I can like get them jobs that way, and I can imagine it could go the other way too. Um, it's good, I think. In terms of like if you're only going into a game jam in order to network and get work, it's the time could probably be spent better in other ways. But game jams are really great. I think are their best for testing your skills. Like I think I'm capable of this, but I don't really know that. I'm gonna go in like a low effort sort of a low commitment sort of way to try this out. It's a good way to find people that you like working with, uh, and to try out game ideas in a really quick way. Uh, so yeah, I'd say join game jams for fun and for education primarily, and they can have some benefit for uh, networking as well. Let's see. If there are any other questions that I haven't addressed, it's because I just missed them in the chat. So feel free to just copy paste and re-ask.
Yeah, and while you guys do that, just to let you know, we are recording this and then we're going to post it to our YouTube channel later tomorrow. And I just shared the link of that in the chat. It should be to our Tech Talk playlist, so you can watch all the previous Tech Talks in there as well. And for future events, you guys can check out our meetup page here. We actually have another event tomorrow. It's going to be a JavaScript game, and I'm sure some of you might be familiar with that Pong game, like the ping pong game. And so the co-founder is actually going to show you guys how to do it in a very basic way. And here is the meetup page for that. If you scroll down, you'll be able to see it. And in case you guys want to keep up with our social media page or website, etc., and all the other links, here's a link tree. And that'll take you to our books, our website, our boot camps, meetup events, YouTube page, Instagram, etc. All right. Any other questions?
See, there's one here about whether you use a laptop or desktop. I've switched between the two. Honestly, with working with clients, sharing things with screen share over Zoom tends to be the best. One place where a laptop is nice is like for my own projects, like if I'm demoing a VR thing um, at an exhibition, having a laptop is less to carry around. But that's pretty rare. Let's see. Version control. Unreal tends to lean towards Perforce for version control since Git can be finicky. What do I prefer for my Unity workflow? I'd say mostly I use Plastic SCM because that's kind of the Unity approved thing for client work. Mostly because once it's set up, that's the least work for the client. They can just like click a couple of buttons to get the changes in. And it's also handles some version conflicts in scenes. For like things that I want to share, GitHub's kind of nice. But I haven't really used GitHub on things where there's like a lot of people working together at the same time. Plastic SCM, I'll put that in the chat. It's built into Unity, so it's like a module that you can bring in. They used to use Collaborate, which was not very good, and Plastic SCM replaced that. Um, let's see, Perforce is great too. One client had a Perforce setup, and yeah, it's excellent. The front loaded work is kind of a lot. So I'd say if you're going to use Perforce, like you need to study that a fair bit compared to some of the other ones. But yeah, if you have a good understanding of how to set up a server and all that sort of thing, and can walk the client through their side of it and like NB tech support yourself, then it's a great option. Okay, that's all I'm seeing.
All right. Well, thank you
Oh,
for answering all those questions and your awesome presentation. Like I said, you guys can watch that back later. But thank you for joining in, Will. We really appreciate it. And thank everyone else for joining as well. And I hope everyone has a great weekend.
all right. Thanks very much.
Bye, guys.
Hey.